So hi friends. So today we are going to discuss about the collection framework. So what is a collection framework? So collection framework is basically the framework in Java to store and manipulate the group of objects, right? So by this only we can store and manipulate the group of objects. Like in array, we have a group of objects, right? In like integer and other things we can store in array, but they are not dynamic in nature. So for the dynamic to resolve that dynamic problem, we introduce the collection framework in Java. Some people introduce the collection framework in Java, and why it is called a framework, because it is optional. You can use it or you can not use it. You can either create your own collection to store the object and manipulate them, and it represents a set of interfaces and classes. It is a ready-made architecture, so that's why it is called a collection framework. And this is the hierarchy of the collection framework. The main class or in the collection framework, it is an interface which is iterable. It is the parent of that collection, and then the collection interface comes. The handy methods, the mainly used methods, always represented by the collection interface. And then we have this list, queue, and set, which all having their own respective properties to store the object in a particular way. The list is having mainly array list, linked list, vector, and stack. These four classes implementation of list, and the queue is having that implementation as priority queue. Then the DQ is the another interface which is extended that queue interface, and the added DQ is implementing that DQ, right? Similarly, the linked list also implementing the DQ. We have list, we have queue, and then we have set. There is hash set and there is link hash set, which are implementing the set interface. And for sorting purposes, we have shorty set. So we will discuss the each and every properties of these particular classes. So there are methods in collection interface which are commonly used by every collection, right? So there is a add method by which we can add a element into the collection. There is add all method by which we can add all, like we have a list and we have another list and we want to add all the elements from the another list into the first list, right? So we can call the add all method at that time. Then we have remove, to remove that element from that collection, and we have remove all to remove all the elements from that collection. uh, then we have another methods, like the commonly used method is the size, clear, contains. So size is to get the size of the collection. It is to clear the collection. It is to remove all the elements from the collection, and it is to uh, the contains method returns a boolean, and it used to search an element inside the collection. Is empty method is a very commonly used method inside the collection. It is checked that whether the collection is empty or not, right? Then we have another methods inside the collection interface, like this remove if. So from Java 8, it is providing us a default method as remove if. So we pass a predicate inside it, and basis of that predicate filter, we will delete all the elements that satisfied that specified predicate. We have this to array to convert this list or any collection inside array into the array, and we can open the stream onto that collection, any collection, because we have that default method in present inside the collection interface. So these are the common methods which we used in collection interface. What is a list interface? So list interface is a child interface of collection interface. It inhabits that links list type of data structure in which we can store the order collection of object. It can have duplicate values, right? So the basic property of list interface is it can have duplicate values. The list interface implemented by four classes: array list, linked list, vector, and stack. There are various methods in list interface that can be used to insert, delete, and access the element from the list. For the array list, uh, basically it uses a dynamic array. The internal data structure of an array list is a dynamic array to store the duplicate element of different data types. The array list class can maintain the insertion order and it is not synchronized. The element stored in the ArrayList class can be randomly accessed. Consider the following element example. So we have created a list, array list basically, and after creating that object, we are just adding the four object here, and we are in this way they are just traversing through that that list actually, and just printing that every element. But there are multiple other methods which by which we can just pass the index and can get the element from the list. Array list example, and here we are just creating a main method, and let us create a list of integer. The name will be list, and we are creating the object as array list. Now we can say like we are adding some elements like this, right? So array list preserve the insertion order. So when I will iterate over this array list by for each loop, so you will see the output. The output is the same way we have inserted the element. We are getting the element in the same way we have inserted them. This is the insertion order, right? 10, 20, 40, 30. So array list preserve list interface preserve the insertion order. You can say, right? And um, we can also check if this list is empty or not by the empty method. It will return a boolean, so we can check if it is false, right? If it is not empty, so we can just print out the list is not empty. So this, because currently it has an element, so it will print this one. We can also print out the size by saying list dot size. The size is currently 4, so it is 4. And there are other methods too, like add and add all, right? We can have index of, so if we are having a object like 10, so we can just check then what is the index of this element. So it is currently at as 0 position, so we can get the index also. The other methods are, we have cleared this one get, you can just pass any index and it will give you that element on that particular index, so it will return 10 for now. Right. And the other method is, the other methods like add all, which can add collections and contains like we can check if it contains 10 or not. Currently it is containing 10, so it will return the boolean which is true because it is containing. But if I will say if it contains 100 or not, it will say false. Similarly, all the uh, list interface implementation classes will implemented these methods, so we can use this method in all the implementation classes like array list, linked list, and other things. But this size and like this contains is currently coming from a collection, so this will be present in all the classes other than which is implemented the list interface, right? So now let's suppose I have a other collection list 2, and I am currently defining it by saying integer, so it like this we are checking the type, so this list will contain only integer types. So what we have done, we have created a new array list. Inside that we have passed two element, we have added two element, and in our first list we are adding this second list by using the add all method which takes the argument as collection. So we have passed this collection, and we can see that the size is increased by 2, and if we print this array list now, it will say the elements are 10, 20, 40, 30, and 50 and 60. So we can print out like this, and we can have a separator also which by which we can just know this is our current output. So in the last, as you can see, there are two more elements in our present list right now. Let's move to linked list, and linked list has the same behavior, but the underlying data structure is doubly linked list. It is also not synchronized, and the insertion order is preserved. The manipulation is fast because no shifting is required in linked list. So linked list, because it is using the linked list data structure, so the manipulation is very fast inside that. Vector and stack are synchronized and part of the list, like part of the list hierarchy. They implement the list interface, and 1 second. Yeah. So stack and vector are the like implementation class of the list, and it is the underlying data structure is also dynamic array, and it is synchronized. It is a like it is the stack class is basically uh, shows that stack functionality, which is first in last out, right? Or last in first out, you can say. And let's come to our queue interface. There we are having two classes. One is our priority queue and second one is our D queue. So because stack is a you can say is a synchronized version inside Java, but if you want to use non-synchronized version of stack, you can use ArrayDQ. And similarly, the priority key is used basically for when we like dealing with heap data structure basically. So yeah, then we come into SAT. SAT is basically it contains that that non-duplicacy, like the element inside a set will not be duplicate will not be allowed inside a set, and we can store one null value. And set is implemented by hash set, linked hash set, and tree set. So link set is a very proper like mostly used um, implementation of set. Linked hash set is used when we want to preserve the um, insertion order also, and tree hash set when we want to just short the set on some order in some order.